In this lecture, we will create a standard load balancer. So we have our AZ900 virtual network that we have defined earlier in this module. The plan is to deploy two web servers, Web Server 01 and Web Server 02, in two different availability zones, AZ1 and AZ2. Let's remember that availability zones represent distinct physical data centers in an Azure region. And why are we doing this? Well, I want my website to be highly available, highly redundant, so in case something goes wrong with an Azure data center, I have available another web server virtual machine that can serve content to my end clients. In this setup, we would need a public load balancer, and that's exactly what we will deploy in this hands-on lab lecture. In order to get started, let's now switch over to Microsoft Azure Portal. Alright, I'm now back in Azure Portal. First, I will select Create a Resource from the top options, and the standard load balancer is part of the networking category, so I will select Networking. As load balancer is not available in the short services featured list, I can select See All at the top, and now I can select Load Balancer. Or if I now go back to Home, we can search Load Balancer in the top search bar, so let's do that, Load Balancer, and I will select Load Balancers. Currently, I have no load balancer defined, so I will select Add option at the top. And now let's continue. Starting from the top, I need to select first the resource group, and I'm going to use my existing AZ900 resource group. Next, let's define a name for our load balancer, for example, AZ900 load balancer. Good, and the region. In my case, I will leave here West Europe, and now the type. What kind of load balancer would you like to deploy? Because this load balancer is public facing and will receive traffic from the internet, I will leave the public option selected and move on to SKU. By the way, what does SKU stand for? A stock keeping unit, or simply SKU, is simply a unique identifier for an item or service sold. So in this case, we see that the load balancer is available in two flavors or options, basic and standard. Because the basic option doesn't support multiple availability zones setup, so this means distributing traffic to virtual machines deployed in different availability zones, we need to select the standard option, which has all the greatest and latest features available. The information point next to SKU highlights some of them, such as backend pool flexibility, high availability ports, but also zonal and zone redundant scenarios, which is actually what we want for our setup. So that's why we need to select the standard option. Alright, let's move on now. Because this is a public load balancer, well, it would need a public IP address. So let's define a name for it. For example, load balancer PIP, public IP address. And by the way, please note that spaces are not allowed when defining the public IP address name. And last option is availability zone. I can select a specific availability zone, part of my region. And what region? Well, in my case, West Europe region, as I selected above. Or I can select zone redundant. And this is what we said we will implement, a zone redundant website running on two different VMs. So here I will choose zone redundant option and move on to tags. Let's choose one tag for our load balancer, for example, cost center. And the value for this tag will be AZ900. And last, I will go to Review and Create, and once validation is passed, I can select Create. And pretty much that's it with the load balancer creation process. It will take 10 to 15 seconds maybe for deployment to complete. Now once it's done, I will select Go to Resource, and now we need to define a couple of things. Remember the steps we have just covered in the previous lecture. Let's take a look at the left-hand side load balancer menu, and we can see under Settings the backend pools. So let's select backend pools, and currently we don't have any defined. I will click Add and provide a backend pool name. So let's call it just like that, backend pool AZ900. And let's select our existing virtual network, and it is our AZ900 VNet. Currently, no virtual machine found in West Europe that matches the above criteria. Well, that's fine, we will add two VMs in the next lecture. I will select Add at the bottom of the page, and configuration should be deployed in just a couple of seconds. So deployment is in progress, and alright, deployment has succeeded, so that's fine. Good, now I also need to create the health probes. So let's select health probes. Again, no results. This is a brand new configuration. So let's select Add. Let's define a name for our health probe. For example, Health Probe AZ900. The protocol is TCP, the port is 80, interval 5, and the unhealthy threshold is 2. So what is the end result of this health probe configuration? What does it mean? And what's really happening behind the scenes? The load balancer will check the state and try to connect through TCP on port 80 to the web servers that are part of the backend pool. And this will happen every 5 seconds, so that's the interval. And the last parameter, unhealthy threshold, is 2. Well, if the load balancer doesn't receive a response back from a virtual machine that it is checking, and 2 consecutive failures occur, then the virtual machine will be declared as not working, not responding. So unhealthy. The result is that the load balancer will stop sending any traffic to that virtual machine once the health probe fails. So the configuration looks good. I will select now OK at the bottom of the page. And now I have a new notification, creating probe, and it should be completed in just a couple of seconds. So here it is, Health Probe AZ900, protocol is TCP, port is 80, and I see that currently is not being used. Now let's tie everything together, and I will select Load Balancing Rules under Settings. Currently no load balancing rules are defined, so let's create our rule now. I will select Add at the top. I have to define a name, for example, Load Balancing Rule AZ900. I am running on IP version 4, so IPv4. Here is the front-end IP address. So this is the IP address that end customers will connect to. So the end customers will not try to connect to a public IP of our virtual machines. They will connect to this front-end IP address assigned to the load balancer, and then connections will be shared to the virtual machine's backend pool. Alright, let's continue. So I receive TCP traffic on port 80, and now backend port, I will forward to the same port to port 80 as well. I will forward this traffic to the backend pool, and backend pool AZ900 is what we have configured, and I'm checking the health state of virtual machines within the backend pool with the health probe AZ900 on TCP port 80. I could also configure session persistence in order to make sure that traffic from a client is handled by a single virtual machine, so the same virtual machine, and not load balanced between multiple VMs. We don't need this at the moment, so I will leave the default none option selected. Great, so configuration is complete. I will now select OK, and the configuration looks good, saving load balancer rule, and I will wait for configuration to finish. Alright, the new load balancing rule is configured and available. So again, we have the front-end IP configuration, and I have the public IP here, good. This is the load balancer PIP, so public IP. I have one rule defined, we have just defined that. The backend pool is backend pool AZ900, and once we define the 2 web servers in the next lecture, we will associate the VMs with this backend pool and will eventually appear here. And last, the health probe is the mechanism that the load balancer uses to check the health state of the virtual machines that are part of the backend pool. Thank you, and I will see you in the next lecture.